in today's session, we have to learn about the DC machine. There are two types of DC machines, DC generator or a DC machine. If we are calling the DC generator, it means what? It will convert mechanical energy into the electrical. And if there is a DC motor, it will work exactly opposite with DC generator. It means what? It can convert electrical energy into the mechanical energy. So that device we can call that machine is used as a DC motor. Actually, if you see their constructions of DC motor and the DC generator, you can see here these are, it is motor and this is the DC generator. What we are doing here, we are converting mechanical energy into electrical or electrical into mechanical. So firstly, see here, this is the constructions for the motor and this is the construction for generator. So here we can say theoretically DC motor and DC generator have the same general construction, because here constructions is exactly same, but what is the difference? Motor will convert electrical into the mechanical energy and generator is converting mechanical energy into the electrical. So for motor, the input energy is, मोटर के लिए मोटर क्या कर रहा है? It is converting electrical into the mechanical. So here input will be the electrical energy and we will get output as a mechanical energy. So here we can say this is the difference between DC motor and the DC generator. If we will see about the DC motor, we can say for DC motor, input is electrical energy and the output will be useful mechanical energy. And if you see the structure for the generator, we can say it is converting input energy, that is nothing but the mechanical, and it will convert that mechanical energy into the electrical energy. So we can say for the generator, input energy is mechanical and output is nothing but electrical energy. If you see the some differences between generator and the DC motor, this is nothing but motor means what? DC motor, and this is the DC generator. Both are doing conversion, but what is the difference? Motor is converting electrical energy into the mechanical and generator is converting mechanical energy to the electrical energy. If you see again in the terms of electricity, what we can say, it is using electricity. DC motor क्या कर रहा है? Electricity को use कर रहा है because it is taking electrical energy as an input. So we can say DC motor uses electrical energy or electricity and DC generator will generate electricity. It is not using, it will generate, that can be used by other. So what we can say, if we see the differences between motor and generator, motor will use electricity and generator will generate electricity. If you see the shaft, shaft is nothing but, if you see the structure of the motor and DC generator, we are using here stator and the rotor. Stator means what? The part of the DC generator or a DC motor that are stationary, that are not flowing. We can call this as a stator. And please, Realme, please mute yourself. Every day I'm saying that you are supposed to join your with your name, but you are not putting your name, Realme, because I will give term work depending on your attendance, depending on your assignment. So just please join the class with your name. Okay. So here we can say it is using electrical energy and DC generator is creating. It means what? We can use that energy which will generated by the DC generator. If you see another difference in the terms of driven element, the shaft of motor is driven by magnetic force developed between armature and the field. For this, firstly, we have to see what is meant by armature, what is meant by shaft. So firstly, we will see the construction of motor and generator, and then again we will see what are the differences. So firstly, in today's session, we will see about the DC generator construction. If you guys see, you can see here this is the basic construction for the DC generator. So we can say we use DC generator to create electrical energy. It is taking mechanical energy and it will convert mechanical energy into the electrical energy. Okay, so see here, this is the construction diagram for the DC generator. In DC generator, we are using yoke. It is nothing but, if you see, this is the outer side. So we can say yoke is the outer frame of the DC machine. We can call this outer surface as a yoke. हम उसको yoke बोल सकते हैं. And what is the use of yoke? It will prevent the whole assembly. It will prevent whole assembly and it will provide mechanical strength. So we can say yoke is the outer frame of the DC machine. It is made up of small generator or large size generator. So we can use to make yoke, we can use cast iron. हम ये जो yoke है, we can made from yoke from the cast iron. And it is acting as a protecting shield for the DC generator. मतलब बाहर के वेदर से, बाहर के जो भी अदर डिवाइसेस है, इट विल प्रिवेंट होल दिस इनसाइडेड सर्किट. हाउ इट इज प्रिवेंटिंग शील्ड फॉर जनरेटर. सो वी कैन से इट इज द प्रोटेक्टिंग शील्ड और इट इज द प्रोटेक्टिंग आउटर फ्रेम फॉर द DC generator. Again, if you see, it provides the mechanical strength to whole assembly, but also it will carry magnetic flux produced by field winding. If you see here the structure of pole, on pole we are using here coil. If you see, we are using their winding, and if there is a concept of winding, there will be EMF introduced. Why? Because there will get us magnetic flux that will be created, due to which EMF will induced here. So we can say this is the structure, this is the circuit, this is the construction diagram for the DC generator, in which we are using yoke, we are using pole, we are using armature, commutator, brushes. We will see one by one. Now you can see this is the pole on which we are using winding. हम उस पे winding कर रहे हैं. So we can say that winding as a field winding, and they are usually made of copper, because copper is a good conductor. That's why we are using here copper to make a field winding. Again, you can say field winding are the former and placed on each pole. If you see the construction diagram for the DC generator, we can see here we are using 4 poles on which we are doing winding. So what we can say, they are wound in such a way that when energized, means if we are giving here mechanical energy, and if we are giving here mechanical energy and it is energized, मतलब उसको energy मिल गया है, at that time they will form alternate now north and south pole. They will form north and south pole. So this is the construction diagram for the DC generator. Again, we see about the armature and the commutator. If you see, armature is nothing but this, ये जो step like, these are nothing but the circular step. This is calling as the armature, and armature conductor, ये जो दो simple point है एक के बाद दो, this we are calling as a armature conductor. So armature core is the rotor of DC machine. And if you see about the yoke, what we can say, yoke is the outer frame. So we can say yoke is the stator of DC generator. Stator means what? If it is not in a moving condition, if it is not rotating, it is remain stationary. So we can say yoke is a stator of the DC generator. And now field winding, we are giving field winding on the pole. We are giving field winding on the pole, so they will generate north and south pole. Now if you see about the function of pole, what we are doing here, when we want to make DC machine, we are using 4 poles, and on that poles we are giving winding. So pole shoots functions. Pole are joined to the yoke with the help of welding. If you see the construction, this is the yoke. What we are doing, we are using pole. On pole we are doing field winding, and we are connecting that pole to the yoke. हम क्या कर रहे हैं, ये जो हमारे पास जो पोल है, we are connecting this to the yoke. So we can say here, poles are joined or connected to the yoke with the help of winding, welding. Again, if you see, it will carry and support the field winding, because here we are giving the winding, so there will be introduction of the mechanical flux. So there will be the concept of EMF. EMF will get induced just because of this field winding which we are doing on the pole shoes. So we can say here, it will support the field winding, and pole core provides this area to wound the field winding. ये pole show में तुम देख सकते हो, we are putting here lots of area on which what we are doing, we are doing the field winding to generate the EMF, because by using DC generator we have to create the electricity. हमें क्या करना है, EMF introduce करना है. So what we are doing here, we are using here poles that can be connected with this yoke by using field winding, and to spread out the flux in air gap, pole core directly introduce magnetic flux through this air gap, armature and to the next pole. मतलब यहाँ पे जो armature है, यहाँ पे जो commutator है and the next pole है, there will be introduction of the magnetic flux, and as magnetic flux will get introduced, EMF will get induced. So this is the construction of yoke. Now we see about the armature. So here we are saying armature is the rotor of the DC machine, because it will rotate. You can see here it is look like this, and this armature coil will rotate. So here we can say it is in a cylindrical shape. Shape देखोगे तो how it is looking? It is looking like a cylinder. So we can say armature is cylindrical in shape with slots to carry armature winding, because there are slots. What we can say here, if you see the structure of the armature, there are the slots. So these slots are used to carry armature winding, and the armature is built from the thin laminated circular steel disc. ये जो armature है, in this device we are using this the armature. So armature is built from the circular steel disc. Okay? It is looking like a circular, and we can make armature by using the steel. So we can say we are using here steel disc for reducing DC current losses, because by using DC generator we have to introduce the electricity. हमें electricity introduce करना है. So what we have to do, we have to reduce the current loss. So we will get higher amount of electricity. It may be provided with air ducts for axial air flow. If you see what we are doing here, we are using mechanical energy and we are creating electrical energy. So if we are converting mechanical energy into the electrical, and at that time there will be introduction of temperature. क्या हो जाएगा वहां पे, टेम्परेचर इंट्रोड्यूस हो जाएगा. सो देयर इज नीड टू मेक कूल. हमें क्या करना है, वो जो हमारा डीसी मशीन है, इफ इट इज बिकमिंग वेरी हॉट, व्हाट विल हैपन, there will be damage of any device inside the DC generator. So what we can do, we can use heat sink and we can make that device cool. So it may be provided with air ducts. So here if you see, there is air duct inside the armature. ये देखो armature का जो structure है, here when we are taking the slots, see here, what we are saying, when we are using the armature core, at that time we are taking air dot, ये छोटे छोटे जो डॉट्स दिख रहे हैं, we can call air dot or we can say holes. We are pretending that we are using these holes to make our device cool. So what we can say, the armature is provided with air duct for axial airflow, and this air will be needed to make our DC generator cool. हम भी फैन यूज करते हैं. Why we will use fan? Because we needed to make, जैसे if you see in the summer बहुत hot temperature होता है, so what we can do, we can make cool. So by using here air dot, हमने क्या किया है, यहाँ पे air dot रखा है. So just because of air dot, air will come and this all devices and the pole will become cool. So we can say here it can be prevented from heat by using the air dot. And armature is keyed to the shaft. It means what? It will be connected with the shaft. If you see armature winding, when we are using the armature, actually it is looking like a circle, but if you see the structure of this armature, it is look like a cylinder, वो cylinder जैसे होता है. But we have taken one dimensional diagram, we have not taken two dimensional, हमने सिर्फ दो ही dimension, two dimensional दिया है. So you can see this is nothing but the cylindrical structure. So we can say here armature winding will have slots that will be used for holding the armature winding. Because here also, जैसे हम पोल पे वाइंडिंग करते हैं, वैसे ही जो हमारा आर्मेचर है, there will be also winding, and these are in the closed circuit. If you see, this is the structure for hardware, how it will look like. This is the construction diagram, how we are making the construction. And if you see practically, it will look like this. You can say it is the cylindrical structure. And on this, if you see, ये copper color का जो दिख रहा है, these are nothing but the coils. How we are using? We are using these coils on the armature, and we are using these coils as the armature winding. And these are in the closed circuit, because what we are saying, outer surface is yoke, उसके अंदर है ये, उसके बाद पोल है, उसके अंदर we will have the armature. So we can say armature winding is in a closed circuit, and it is connected in series to parallel for enhancing the sum of produced current. Because by using the DC generator, we have to create electricity. So we can say here armature can be constructed by silicon steel. हम क्या बोल रहे हैं, ये जो है armature, we can made armature by using the steel disc. And the thickness of this disc we will keep very small to reduce the losses. हम क्या कर सकते हैं, इसका जो एरिया है, we can put that thickness to very small size. The core is divided into packets to facilitate ventilation. We are taking here air dots, so air will come and our whole circuit of the DC generator will become cool. Then we have to see about the commutator. This is the same construction diagram for the DC generator. What we have to see? We have to see all these parts. We have seen about yoke, we have seen about the pole, about the field winding which we are doing on the pole. Then we have seen armature, and there is a winding on the armature. Now we have to see about the commutator. Armature के अंदर, if you see, this is how it will look like. Commutator ऐसे रहेगा, and where it will be? It will be inside the armature. ये armature के अंदर है. So what we can say, the working of commutator is look like a rectifier. Rectifier means what? We can use rectifier to increase the value of voltage. We can convert AC voltage into the DC by using the rectifier. So we can say here commutator, ये जो अंदर के साइड है, this is the commutator, ये सर्कल में जो बॉक्सेस के साइड है. So we can say The working of a commutator is like a rectifier. It means what? It can convert AC voltage into the DC voltage within the within the armature winding. ये जो outer side है, it is nothing but the armature winding. So we can say pole is inside of the DC generator. It is inside of yoke. There will be winding on the pole. Again, inside the pole there is a commutator. On commutator we are putting air dot to prevent from hitting. मतलब वो क्या कर रहा है, एयर को अंदर आने दे रहा है, so that device will become cool. Again, inside the commutator there is a armature, and we are saying armature will work as a rectifier. It can convert AC voltage into the DC voltage, and it will be made up of the copper segment. You can see here commutator we are making from copper because it is a good conductor. So each copper segment will protect from each other with the help of mica sheets. If you see, we are using here copper because it is a good conductor, and we are using copper to make the commutator. And here also, if there are lots of commutators, so what we can do, we can prevent commutator from other with the help of mica sheets. It is located on the shaft of machine. It will be at the shaft of machine. If you see, we will get here AC voltage in positive as well as in negative. So what? By using the commutator, we can work as a rectifier. We can convert AC voltage into the DC voltage. So this is the constructions for the commutator. Now we see about the brushes. We are using here, if you see the construction of the, this is the armature, and if you see on the armature there are four black, we are calling these are nothing but the brushes, and these brushes will used in the armature. These electrical connections can be ensured between commutator and the exterior load circuit. मतलब we can make here electrical connections between this commutator and the outer side. We can make the connections between commutator and the outer side by using these brushes. So वो brush क्या कर रहा है? It is only helping to make connection of commutator with external load circuit. जो हम बाहर से कोई भी external दे रहे हो तो we can connect by using the brush box, and they will collect current from the commutator, and brushes are made up of the carbon or the graphite. These are made up from the carbon and the graphite. Now if you see, this is the construction diagram for the DC generator. In exam there will be question like explain DC generator with the help of construction diagram. At that time you are supposed to draw this diagram, and you are supposed to explain these things in 2 to 3 points. It means what? You can explain like yoke is the outer surface of the DC generator. It is working as the protective for remaining circuit. And again, if you say pole, we are using here pole which are inside the yoke. We are doing here winding. Again, there is a armature and a commutator. So we can say we are taking the armature, and we are making armature by using the copper because it is a good conductor, and we are taking their air dots to come up air. Again, we are using their commutator. Commutator are inside the armature, and we are using their brushes on the commutator to make interconnections between our DC generator and the other device. I have given here all the descriptions for the parts which we are using in a DC generator. Sometime there will be question on explain the work of yoke and pole shoes in the DC generator. So what we have to do? That question will be for 4 marks. So we have to explain how yoke is working and how pole shoe is working. So here you can say in DC generator we are using yoke, field winding, pole coil, pole shoes, we are using armature, armature winding, commutator winding. So we can say yoke will made up from the iron and it will cover it will cover all the remaining parts of the DC generator because it is a outer surface of the DC generator and it will act as a protecting shield because it is protecting our DC generator from external load. It will provide mechanical support for the pole because we are taking the pole inside the yoke. So we can say it is providing mechanical support. It will carry magnetic flux produced by pole because it is supposed to create the EMF. It is supposed to generate electricity. So it is using magnetic flux which will be introduced by pole. We can make pole by using the copper. Each pole has one or more field winding. We are using here winding to, we are placed over it to produce the magnetic field. So we can say here each pole will have number of field winding and it will produce the magnetic field. Field coil are the former and it will wound or it will connected in series because we see we are using here 4 poles. So these are in the series. How we are connecting? We are connecting by using the field winding. हमने क्या किया है? Field winding. You guys can see here. इसका जो field winding है, वायर के थ्रू इसको कनेक्शन दिया है. So fields, they are wound in such a way that when they will get energized, they will form magnetic flux. So they will form magnetic, मतलब magnet क्या होता है? There will be 2 poles. These poles are nothing but south and the north. So we can say they are wound in a such a way that when they will energize, they will form north and the south pole. If you see about the pole shoes, we can make pole by using the thin cast steel or we can make it by using the iron lamination. We are using pole, we are joining this pole with the yoke with the help of field winding and it will carry support to the field winding because we are doing winding on the, you can see here we are doing field winding on the pole. So we can say here it will carry and support the field winding. To support the field winding, pole covers this area to wound the field winding because they are having lots of area on a pole. Pole पे बहुत सारा area है, so we can give support to that field winding. Again, on pole, if you see, it will provide the support as well as to spread out the flux in the air gap because when we are using the commutator at that time we are putting their air, at that time we are putting their air dot. Why we are putting their air dot? For the air come as well as you will get the electromagnetic flux which are introduced by field winding of a pole. तो ये क्या करेगा? ये जो field winding है, it will spread out the flux in that air gap. So pole core directly take magnetic flux and it will generate EMF by giving this magnetic flux to other pole. You can see these poles are interconnected with each other. So whenever magnetic flux are generated by the field winding of pole, at that time they are spreading that magnetic flux to they are giving this magnetic flux to the air gap which we are having on the commutator because by using the DC generator we have to create the EMF. Now we will see about the armature. We can make armature by using the circular silicon steel disc and it is used silicon steel disc to reduce the current losses. And armature core is the rotor part of the DC generator. DC generator and the DC motor. Both constructions are same. So what we can say, Armature is the rotor part of the DC machine, means DC motor and the DC generator, and it will be in the cylindrical shape, and it is having small, sorry, slots to carry the armature winding. If you see, we are putting their slots. ये हमने थोड़े slots रखे हैं step up function के जैसे. We are putting their slots so to carry the armature winding, and it may provided with the air ducts which are on the commutator. So we can use their air dots to make that device cool. So armature is the key to the shaft. Armature winding, we can give winding by using the copper, because copper is a good conductor. तो हम क्या कर सकते हैं? Winding, we have to introduce magnetic flux, and as magnetic flux will get induced, we will get the EMF. So we can say armature is the heart of this machine, because what it is doing, it is generating EMF. So we can call it is the heart of DC machine, and it will reduces current losses. Armature core slots are having air gap to make our DC machine cool. They are used they are used for holding armature winding. ये जो छोटे छोटे slots है, you can see here I have put it here two points. These are nothing but the slots in armature winding. So we are using that winding, we can make winding on that slots. So we can say armature core holds slots that can be used for the making armature winding, and these are in the closed circuit because they are inside the yoke. So we can say armature winding will be on the slot of armature, and it will be inside the closed circuit. Again, there is a commutator. We can make commutator by using number of weight shaped hard drawn copper bar. It means what? Here also we are using the copper bar. Also we are using well shaped hard drawn copper to prevent that circuit from the other, and to prevent that circuit from the shaft. So we can say we can use commutator as a rectifier, and we can convert AC voltage into the DC voltage within the armature winding, because if you see the constructions, commutator is inside the brushes and the armature, inside the brushes and the commutator. This is nothing but the commutator. So what we can say, armature is inside the commutator and brushes, and armature we can use as a rectifier, so it can convert AC voltage into the DC voltage, and it is located on the shaft of machine. Now we are saying when we are using the DC generator, we are using mechanical energy, and we are converting that mechanical energy into the EMF. EMF is nothing but it is the potential difference, or we can say it is the voltage. So what we can say here, when we have to see the EMF introduced in the DC generator, we can calculate as let consider P is nothing but the number of poles of the machine. If you see our DC generator, we are using 4 poles. Then phi. Phi is nothing but flux per pole, because there will be magnetic flux will get introduced, because we are using their winding. हम इंडक्टर यूज करके क्या कर रहे हैं, वहां पे वाइंडिंग कर रहे हैं पोल पे. सो देयर विल बी जनरेशन ऑफ द मैग्नेटिक फ्लक्स. So we can denote magnetic flux by using phi. Z is the total number of armature conductor. We are using their armature. So Z is nothing but it is the number of armature we are using. N is speed of armature in rotation per minute. RPM is nothing but rotation per minute. So we can say it is measuring the speed. And we know armature is rotating. Armature is the rotor. So we can say N is the speed of armature. A is the number of parallel paths in the armature winding. So first, if you are calculating the flux, which are generated only by one conductor. So that will be P5 Weber. We can give unit for flux as a Weber. जैसे हम voltage को volt देते हैं, current को I देते हैं, like this. If we are measuring the EMF, we are measuring the flux, then we can use flux by using the unit Weber. And time taken to complete one revolution. So we are saying when we will get one revolution, that time flux are generated P5. And time we can measure as T equal to 60 by n seconds. Because we know 1 minute is nothing but 60. So one revolutions will be T equal to, I have given here how we are taking T equal to 60 by n. One revolutions will be T. So T will be 1 by n. And in minute, so we can take minute का conversion करोगे तो what we will get here 60. So we can take T equal to 60 and we can take number of rotation n will be 60 upon T, or we can write that equation in the form of T. So we can say to make n revolutions, if it is taking time T, we can calculate the time in the form of number of revolutions. So we can calculate T equal to 60 by n, and we can measure time in the second. Here we have finished about the DC generator. EMF equation we will see tomorrow because only 1 minute is remaining. If anyone is facing any issue, you can ask me. We are using DC generator to convert mechanical energy into the electrical energy, and the construction of DC generator and DC motor are having same general construction. We are using commutator, armature winding, we are using pole and yoke in the DC generator and the DC machine, DC motor. Now I am taking your attendance. If anyone is having any issue, you can ask me. Okay, thank you. We can conclude our class.